Verify ready for launch. FTS.
FTS go.
Prop go. ABI.
ABI's go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
You're looking at a live view of 8:34 p.m. Eastern Standard Time from the Space Center in Florida. Thanks for logging in for the SpainSat NG I mission, SpaceX's 13th mission of the year. I'm John Innsbrucker, and I'm the Principal Integration Engineer for Falcon here at SpaceX in Hawthorne, California. Today we are launching the SpainSat NG I satellite to a geostationary transfer orbit on behalf of our customer, ISDASat. ISDASat is a government satellite operator and services provider operating secure communication satellites, synthetic aperture Earth observation satellites, and maritime monitoring. ISDASat has provided Earth observation services with radar technology through the PATH satellite, which SpaceX launched on a Falcon 9 back in 2018. SpainSat NG is a new program developed by ISDASat to improve the secure satellite communications and defense capabilities of the Spanish government, its allies, and international organizations, including the European Union's GovSatcom and NATO. SpainSat will cover an extensive area that ranges from the United States and South America to the Middle East, Africa, and Europe, reaching as far as Singapore. Now we're currently at T-minus 11 minutes 25 seconds and counting. We're looking good for an on-time liftoff. However, if for any reason we are unable to launch today, a backup opportunity is available tomorrow at the same time. But the good news is Falcon 9 is healthy, the range is ready to support, the weather's been good all day and continues to look outstanding. We're not tracking any concerns for launch in just over 11 minutes. And with that, let's take a look at today's Falcon 9. The two-stage Falcon 9 you can see on your screen with its payload fairing is 70 meters or 229 feet tall. When it's fully loaded, it'll hold just over 1 million pounds of propellant, which the vehicle will burn through in less than 3 minutes after liftoff. Propellant loading did begin on time at T-minus 35 minutes this evening. The second stage fuel tank is fully loaded. The first stage fuel tank loading will complete at T-minus 6 minutes. Liquid oxygen loading is underway on both stages. Now our payload today is safely enclosed inside of the 17-foot diameter payload fairing, which is a structure called out at the very top of the graphic. It's made of a carbon composite material, and the two sides of the fairing form a clamshell around the satellite to protect it during ascent. Now the fairing halves are then separated at about 3 minutes and 40 seconds into today's flight. They'll be recovered from the ocean for reuse. Now the fairing halves supporting today's mission are flight proven. One half is flying for its 8th time. The other half is flying for its 5th time. Now below the payload fairing, you can see the second stage. That's the part of the rocket that will take our payload to its destination orbit today. The second stage will ignite its single Merlin vacuum engine, or MVAC for short, at 2 minutes 50 seconds into flight. It'll relight a second time before we deploy the satellite. Below the second stage, you can see on the graphic the first stage. And it starts with the black inner stage, which is part of the first stage booster. The carbon fiber inner stage is that distinct black color. That's the thermal protection system on the outside of the inner stage. Now at the bottom of the first stage are the 9 Merlin engines. You can't see them in this view, but they are obviously at the bottom of the first stage, and they'll propel Falcon 9 off the ground up to the thinner parts of Earth's atmosphere. Now, the first stage is designed to be reflown with minimal refurbishment between flights, with today marking the 21st flight for this particular booster. However, due to the performance required for today's mission, this will be the final flight for this Falcon 9 first stage. During its 21 missions, this single first stage has launched a lunar lander to the moon, critical supplies and research to the International Space Station, over 400 Starlink satellites to orbit, and much more since its first launch in May 2022. Finally, alongside the vehicle, the large truss structure you see, that's part of the transporter erector, what we call the TE. We use the TE both to roll the rocket out to the pad and then to raise it to its vertical launch position. At liftoff, it will retract in order to clear the way for Falcon 9's ascent. Now, while the countdown continues, coming up on T-minus 8 minutes, let's find more about the satellite we're delivering to orbit today, SpainSat NG I.
The SpainSat NG program will provide a sovereign, secure communications capability for government missions, with 2 new generation satellites based on Airbus's Eurostar Neo platform, which is developed under the European Space Agency's partnership projects. The SpainSat NG program is under the responsibility of Istisat.
Istisat is an international service provider of X and military Ka-band for government and military applications. Our role in the program SpainSat NG is to be the customer of the full program, including the space and ground segment, the launch, and the operation and exploitation of the satellite during 15 years lifetime.
What's unique about the SpainSat NG program is the PASIS 3 funding partnership model.
PASIS 3 is a financial scheme to develop the most innovative elements of the SpainSat NG payload with the support of the Center for Technological and Industrial Development, CVTI, in a framework of a private-public partnership between the European Space Agency and Istisat as an operator of the sat.
The most innovative element of the payload is the X-band active antenna system, comprising both receive and transmit antennas.
Something as complex as the DRA's antenna in X-band, an active antenna that can move the beams electronically and can configure the beam electronically without any movement, is what makes this satellite the most advanced one in Europe today.
These active antennas are at the cutting edge of new technology, with beam hopping and geolocation capabilities enabling artificial intelligence, big data, and the Internet of Things on the ground. The antennas are being developed by Airbus, which is leading a consortium of 5 Spanish space companies.
The active antennas are already in production. Actually, they are in the assembly, integration, and test phase. That is the last phase before delivery of the antenna. It's done in Barajas site in Airbus Defense Space in Spain, and it will be delivered to Toulouse.
For SpainSat NG I, the mating between the communication module and the service module has taken place in Airbus facilities in Toulouse. This was the first step of the final satellite AIT phase.
The SpainSat NG program has been a very good example of institutional and industrial collaboration. In the industrial part, it has been a very good collaboration between the 2 main industries in Europe, being Airbus and Thales Aerospace, including all the Spanish industries in this important program.
Airbus works to safeguard Europe's citizens and strategic autonomy. Through SpainSat NG, it will provide secure, resilient, and flexible communications for those who keep us safe.
T-minus 4 minutes, 26 seconds and counting. We've just heard the call out, strong back lower has begun. It's actually a sequence that'll start with the clamp arms beginning to open. You'll see those right now in the monitor. You can see the arms are on the top of the second stage. We open those in preparation for the strong back pulling away from the rocket. And you can see the arms coming open now. Next up will be retract to the strong back. Now the transport erector we talked about has two components, the strong back that runs alongside the Falcon 9 and a launch mount underneath. The launch mount under the Falcon 9 has the 4 hold downs that release at T0. The strong back along the side is hinged to the launch mount, and it will rotate right now about 2 degrees away from the vehicle, and you can just start to see that motion beginning. Now at liftoff, the strong back will then move to a position 45 degrees away from the Falcon, and that clears the way for launch of the launch vehicle. Completing the recline. Now at this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of the kerosene fuel and liquid oxygen. First stage loading should complete here momentarily. We're waiting for the call out. And then about a minute later, second stage of liquid oxygen loading should complete. Now the white clouds...
Stage 1 LOX load is complete.
Stage 1 LOX load complete. We're on time. We're down to one more tank to finish loading. Stage 2 LOX. The white clouds that you're seeing around the vehicle, they're formed as the chilled gas vents overboard to maintain pressure in the tanks as needed. Current temperature at the launch site's a balmy 63 Fahrenheit, 17 Celsius. And when the gas meets that warm Florida air, it condenses the moisture in the air and it forms those clouds. As we wait for T-minus 2 minutes and the start of the second stage LOX closeout, a few more things that'll happen in the last part of the countdown. At T-minus 60 seconds, Falcon 9 will be in startup. That means the rocket's autonomous internal flight computers have taken over the launch countdown. There are computers on both the first and second stages.
Stage 2 LOX load is complete.
LOX load complete on second stage. That means the 1 million pounds propellant is completely loaded now on both the first and the second stages. Next major activity is going to come up at T-minus 1 minute 30 seconds. That's going to be the ground gas closeouts. We'll begin venting pressures in the strong back overboard. Make sure everything is drained in preparation for launch.
Gas launch closeouts has started.
There we go. The gas closeouts have begun. Next major event will be T-minus 1 minute. As I mentioned, the Falcon flight computers will go into startup. One comment, I mentioned there were flight computers on both stages. During ascent, the second stage flight computer is the master. As we count down at T-minus 2 seconds, we'll begin the Merlin 1D engine ignition sequence. The flight computers will command the hold downs to release at T0.
Falcon 9 is in startup.
Falcon 9's gone into startup. The flight computers are now controlling the launch vehicle. Falcon 9's looking good. SpainSat is ready to go. Falcon 9 team's working no issues. The weather is excellent. The range is ready.
Launch director, go for launch.
And the launch directors go for launch. Let's listen in to the flight of SpainSat NG I.
T-minus 30. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, liftoff. Go SpaceX, go SpainSat NG I.
Vehicles pitching downrange.
Stage 1 propulsion is nominal.
T plus 30 seconds, Falcon 9 has successfully lifted off from Complex 39A at Kennedy Space Center. We can hear the characteristic rumble as the first stage heads into space. We're throttling down right now in preparation
Power and telemetry nominal.
for max Q. Good call out, power and telemetry nominal, reports avionics.
Falcon 9 is supersonic.
And we have throttled back up to power.
Max Q.
And we've heard the max Q call out. Continuing on the timeline, everything looking good. The rocket typically will need to go 17,000 miles per hour horizontally in order to get into orbit and avoid being pulled back down to Earth. To help go from vertical to horizontal, the first stage performed a pitch kick just after liftoff, about 10 seconds into flight, or what's also known as a gravity turn. The engines gimbal a small amount, and that slowly turns the first stage from going straight up to going horizontal with the help of gravity, and eventually we will be roughly horizontal to Earth as we achieve orbit. Now you can track the progress to orbit by keeping an eye on the left side of your display. That's showing the first stage velocity and altitude, and then we'll have displays for the second stage as we get past stage separation. Now we're going to have coming up in about 30 seconds the start of the typical 3 quick events. Main engine cutoff, or MECO, you'll hear the call out. We'll shut down the 9 Merlin engines on the first stage. The pneumatic system, the stage separation pushers, will then push the first stage away from the second stage for stage separation, and the MVAC-D engine will ignite, and then fairing separation. For now, let's listen and watch for the events.
Main engine cutoff.
Stage separation confirmed.
MVAC ignition.
And there you heard and saw those events that happened back to back to back. We had main engine cutoff, stage sep, and second stage engine start number 1, SES-1. Right-hand side, you can see the altitude and the velocity of the second stage. So far, I want to remind folks who might be waiting for it, as we talked about earlier in the webcast, the first stage will not be recovered today. You may have noticed that we removed the landing legs and the grid fins to decrease the mass of the stage. That'll provide the performance needed to put the 6 metric ton spacecraft into orbit. The legs and fins can be used on other boosters. But now we want to say to the first stage,
Fairing separation confirmed.
Fairing separation on time. And for first stage that is on its way back to Earth, not for recovery, farewell, and we thank you. Now the fairing halves that you just saw separate from around the SpainSat NG I spacecraft, we'll be attempting to retrieve those halves once they fall back to Earth using our recovery vessel Bob. Now the fairings will orient themselves as they come back down with gas thrusters for entry into the atmosphere. And as they near the ocean, each fairing half uses a gas-powered deployer to release a parachute. The fairing computer will send commands that steer the fairings to the ocean landing, where the recovery vessel Bob will attempt to recover them. Now we've got a few minutes until our next major event, SECO-1, which is where we'll shut down our MVAC-D engine on the second stage in the parking orbit.
Stage 1 FTS has safed.
Coming up on 5 minutes, everything continuing to look good. You can see the orange-red glow of the niobium alloy nozzle extension on the second stage engine. Very standard for the MVAC-D engine. 5 minutes, everything continues to look good. Now you'll notice the speed continuing to increase on the display for stage 2. That speed is obviously increasing. That's because the acceleration is going to increase throughout the burn. The thrust of the MVAC-D engine, just over 220,000 pounds of thrust in vacuum, stays constant during the burn. But as we burn off the propellant, the mass is decreasing. And so for those who remember force equal mass times acceleration, if the force is constant but the mass decreases, the acceleration is going to increase. For this first burn, the stack will be doing about 3.8 G's acceleration as we get to SECO-1. T plus 6 minutes, continuing to look good on the second stage. SpainSat NG I attached to the top of the second stage. We'll see some views from the forward-looking
Vehicles
camera
on a nominal trajectory.
a little later on. The GNC, the Guidance, Navigation, and Control Engineer, calling out the nominal trajectory for the stage. Six and a half minutes into flight, continuing to look good on the burn. Next major event's going to come up a little bit after 7 minutes. We should hear a call out of terminal guidance on the second stage as we begin to get ready for shutdown at T plus 8 minutes and 1 second.
Stage 2 is in terminal guidance.
There's the call out from GNC. Second stage flight computer is now moving into a state where it's preparing for that second stage engine cutoff. We're calculating the velocity required to get to orbit. You have to understand how fast you're going horizontally as well as away from the Earth. And then we have to come up with the commands that are going to go to the actuators so that we can command pitch and yaw to make sure that the second stage aims itself, so to speak, to achieve the desired orbital parameter. Now, final velocity for this first burn is aimed for about 7.5 kilometers per second. That's going to be just under that 17,000 mile an hour figure we need for a low Earth parking orbit. And 7.5 kilometers per second, that is the rule of thumb for the velocity you need to get into an Earth orbit when you're launching eastwardly, for example, out of Kennedy. Shutdown of the MVAC, we're going to wait for guidance to tell us how the orbit looks.
Nominal orbit insertion.
And confirmation, nominal orbit insertion. We're through second stage engine cutoff number 1, SECA 1. We're right where we want to be in orbit. Now, the second stage, and we've got another nice view looking forward from the payload attached fitting up at SpainSat NG I. We'll have more views as we go through the webcast, but for now, we're embarking on a coast phase on the second stage, spacecraft still attached. Following this coast, we will relight the MVAC engine for a second time. That's going to happen around T plus 26.5 minute mark. And then about 4.5 minutes after that, at T plus 31 minutes, we will actually get to spacecraft separation. For that, we're going to halt the live commentary for a while. We'll be back in about 16 minutes at T plus 25, but we'll leave you with the visuals from space. John Innsbrucker. Live commentary. We're just past T plus 25 minutes. You're looking at a view of the MVAC-D engine as we're coming up in about a minute and a half on the second burn of that engine, placing the SpainSat NG I satellite into the desired transfer orbit. A quick recap, we had an on-time liftoff at 8:34 p.m. Eastern Standard Time from 39A at Kennedy Space Center. Successful first stage shutdown, stage separation. We had a good burn on the second stage engine. We also had the fairing separation that we saw. Fairing halves back to the ocean right now where they'll be recovered. One fairing half, that was its 8th flight. The other one was its 5th flight. We also then got into the desired orbit, and that's where we are right now, finishing up a coast phase. And we're just about 35 seconds away from relight of the MVAC engine for the second time. And that'll propel the stack into the desired geostationary transfer orbit. Waiting right now for the last seconds as the flight computer counts down to the ignition of the engine. Ignition of the MVAC-D engine. Now this burn's going to last about 67 seconds. That's typical for a geostationary mission. If you're watching the speed gauge on the right-hand side of the display, you're going to see that we're going to add about 2,500 meters per second to the velocity of the second stage, which is still carrying the SpainSat NG I payload on top. Now during this burn, as we continue burning off the remainder of the propellant, the acceleration will reach 4.8 G at the end of the burn. This is about 1 G more acceleration than we had on the first burn of the second stage when we had a lot more propellant on board. Engine now throttling down, decreasing the loads on the spacecraft as we're coming up, and we have SECO 2.
Nominal orbit insertion.
And there's the big call out for the day, nominal orbit insertion. Second stage in its second burn has put the spacecraft onto the desired trajectory. You can see right now 400 kilometers, 440 kilometers in altitude. We're headed to an orbit much higher than that. Next up, we're going to have separation of the second stage, of the SpainSat NG I spacecraft. We've got a couple of minutes before that happens. We'll come back with live commentary at about T plus 30 minutes. T plus 30 minutes, 32 seconds. Everything continues to look good. Welcome back to SpainSat NG I mission coverage. Had a great mission so far. We're less than a minute away from payload deploy for our customer, Está. Now today's satellite will be placed into geostationary orbit at 29 degrees east longitude. A second satellite known as SpainSat NG I will be placed in a geostationary position at 30 degrees west longitude later this year. And the SpainSat satellites will replace the existing SpainSat launched in 2006 and the XTAR EUR launched in 2005. The view right now looking up from the camera on the second stage mounted on the payload attached fitting. You're looking at the bottom of SpainSat NG I. And we're waiting for payload deploy.
SpainSat NG I deploy confirmed.
Avionics engineer calling out successful deploy. You can see it on the screen. Springs pushing the second stage and the SpainSat NG I spacecraft away from each other. And with that successful deploy of SpainSat NG I satellite, it begins its journey to its final destination. With that, that's going to wrap up our coverage for today. All of us at SpaceX want to give a big thank you to our customer Está. We also want to give a shout out to the Eastern Range, Kennedy Space Center, and the Federal Aviation Administration for supporting today's launch. And as always, thanks to all our viewers for logging on and your continued support. Be sure to follow us using @SpaceX on X for mission updates. I'm John Innsbrucker. We'll see you again soon.